In Alien Dictionary we are given a list of words that are already sorted in the alien language's lexicographic order. Our job is to figure out the order of characters in that alphabet. If that claim is incorrect and the given order cannot correspond to any valid letter order, for example if the graph has a cycle, we return an empty string. Example 1, WRT, WRF, ETT, RFTT gives one valid order WERTF. Example 2, Z, X, Z is invalid. From the first pair we get Z before X, from the second pair we get X before Z. That's a cycle, so there is no valid order and we return empty string. In simple terms, we get clues about letter order by comparing consecutive words. Where two words first differ, the letter in the first word comes before the letter in the second. We put these clues into a directed graph, then run topological sort to get a valid order. If the clues conflict, for example if we get a cycle, there is no valid alphabet order. The approach has two parts. First, we build a directed graph where an edge from A to B means character A comes before B in the alien alphabet. Second, we run topological sort on that graph to get a valid character order. We have a separate tutorial on topological sort. Here we focus on the trickier part, how to build the graph by looping through the words. The tricky part is building the graph. We loop through adjacent pairs of words. For each pair, we compare character by character and find the first position where they differ. The character in the first word at that position comes before the character in the second word, so we add a directed edge from the first to the second. Why do we stop at the first difference? Because in lexicographic order, the first position where the words differ is exactly what determines which word comes first. Later positions do not decide the order for this pair. So we take one edge per pair and move on. If we never find a difference and the first word is longer than the second, that's invalid, like ABC before up. We also need every character as a vertex. Once the graph is built, we run topological sort. See the topological sort tutorial for that step. In the solution we first see how a single pair of adjacent words yields one edge. Then we run through the full example with all pairs. For the pair WRF and we compare index 0, W versus E. They differ, so W comes before E in the alien alphabet. We add a single edge from W to E and we're done with this pair. We stop at the first difference because in dictionary order, that's the only position that tells us which word comes first for this pair. We don't need to look at later positions. Let's run through the full example. We have 5 words. Pair 1, WRT and WRF. First difference at index 2, T and F. So T comes before F, we add edge T to F, pair 2, WRF and First difference at index 0, W and E. Add edge W to E, pair 3, and ETT. First difference at index 1, R and T. Add edge R to T, pair 4, ETT and RFTT. First difference at index 0, E and R. Add edge E to R. Every character W, E, R, T, F is a vertex. Now we run topological sort on this graph. See the topological sort tutorial for how that works. One valid order is WERTF. Time is O of C, where C is the total number of characters in all words. We loop through the words to build the graph and run topological sort on at most 26 nodes. Space is O of 1 because the alphabet size is fixed. The graph has at most 26 vertices and a bounded number of edges. Here is the pseudocode for Alien Dictionary. We build the graph by looping over adjacent words, then we run topological sort. Frame 2 shows the BFS-based topological sort. We build a directed graph and collect every character that appears in any word. Loop over each adjacent pair of words, words I and words I plus 1. Let A and B be the two words we're comparing. Compare character by character up to the length of the shorter word. When we find the first position where they differ, add a directed edge from the character in the first word to the character in the second. We only take the first difference, one edge per pair. If we never found a difference but the first word is longer than the second, that's invalid. Return empty string, for example ABC before ab is invalid. Make sure every character is a vertex in the graph, even if it has no edges. Run topological sort on the graph, bfs/con, return empty string if there is a cycle. Return the topological order as a string. Topological sort using Con's algorithm, BFS with indegree. Compute indegree for each vertex, start with a queue of vertices with indegree 0. Repeatedly dequeue a vertex, add it to the result, and decrement indegree of its neighbors, enqueue any neighbor whose indegree becomes 0. If the result has fewer than n vertices, the graph has a cycle and we return invalid.